Okay, this video is going to give just a real basic overview and backgrounder on steam heating, so we can have additional videos that go into more depth about some of the issues going on with the AGC boiler. First of all, it is a boiler, so it's steam, not hot water. Sometimes people are confused by that. It does actually generate steam, and it looks somewhat like this. It is the source of heat for the office side of the church, the two floors, the chapel and so on, and in the upstairs offices is all radiator steam heat. The other side of the building, the sanctuary, Ackerman Hall, narthex, all of that is forced air, and that's what was replaced recently with the 5 new forced air furnaces. The boiler is about 12 years old. It was replaced in about 1990, I believe, 92, somewhere in there. And of course the piping and the radiators and so on are all original to the building, about 85 years old. So this is a Burnham Series 5B, and it looks just like this. However, we only have one section. This comes in multiple sections, so we have one section. And we'll have some video here shortly of the actual unit, but what I want to do is just show you some of the controls so you can see that it's really fairly easy to understand what's going on with the boiler. All this is a big cast iron tank. It's actually sections in here and so on. But it holds about 50 gallons of water, and it boils the water and makes steam. It's just that simple. So underneath here is a big old burner. It goes underneath the entire section of cast iron firing tubes, and then this fills full of water to a certain level, and then the steam comes off. And there's two very, very large pipes, which is sometimes confusing when people see why there's two pipes, but that's because we need to equalize the pressure here, and we have more and more sections. We have to have more and more pipes. Now, I'm not going to get into all of the physics of the header and the Hartford loop and all this kind of stuff, but there is some funky looking piping up here where they're combined, and it actually comes down and then back up around like this, and it goes up into the headers, and there's a reason for that, and it's for safety reasons and for getting dry steam, so that the moisture drops off of the steam, because you don't want water to carry with it. It's called carryover. Now, safety is extremely important, because steam has the potential of doing major damage. Even a small boiler like this one could take out a section of the building easily. A Burnham boiler of about half this size blew up about 3 years ago in Ingrid Grove Heights, I believe. It's on the State of Minnesota website, and it took out a good part of the house. The larger boilers, you can see pictures, take out entire plants, city blocks, things like that. So if you've seen a water heater like a Mythbusters blow up or something, you can see that they really take off. But this is a cast iron, and this is built for like 600 pounds burst pressure, which is several times that of a water heater. Has certainly a lot more heat going into it, and it's designed to deal with steam, not just hot water. So it's got a lot of potential for devastation and damage. So most of the controls are centered around safety, and that's why it requires a licensed operator and has to be signed off and all that kind of stuff. The first thing we're concerned about is low water. If this goes too low, that's not a good thing. As it produces steam, of course the water level drops, and then it gets made up with a pump. But to monitor that, we have a valve sitting out here, and it's like a coffee pot. Have you ever seen those things on a coffee pot where they have a pipe coming around and then a little glass so you can see how much coffee is in the coffee pot? We actually have those on here as well. Those are just called sight glasses, and I'm just going to draw one over here, and it's just a glass tube like that, and then since you can't see the water, of course, you'll be able to see the water level like that in the glass tube. So that's a fairly common thing. You'll be able to see it kind of go up and down, oscillate, and so on. But over here we got the same concept with the tube coming through, but inside of this big ball, and what this is called a low water cutoff valve, and the easiest way to think of it is like the float valve in the back of your toilet. You've looked at that, where it's just a big plastic ball filled full of air, and it rides on top of the water. As the water goes down, it goes down and it goes back up again. But as it does that, it activates a switch. Same thing here. The only difference is this is made out of some industrial strength steel, and the ball inside is also steel, but it's just a float valve. Just got to float a ball in there, and then it comes out with a little arm, and it's got a switch on there. So this is called a low water cutoff valve, and it's a model 150 just for reference purposes. It actually has two switches and two levels. So the first one is going to be just slightly below the operating level, the safe operating level of water. And when it reaches that level, that switch engages, which turns on the feed pump. So over here is a tank. And in that tank is feed water, and that comes from the condensate coming back from the radiators, and we'll get to that in a second here. The condensate comes back, goes into this tank, and just kind of hangs out there, and there's this big old pump on that that feeds into the back of the boiler. So when the water drops to this level, the low water cutoff valve kicks in and turns that pump on enough until it comes back up and turns that switch off again. So it just, that little float thing just goes up and down. It's got a second switch slightly below that, which is the actual low water cutoff, commonly called low water cutoff valve, but that first is a feed water switch. The second one, which is slightly lower than that, is the low water cutoff, and it says if it gets to be that level, then we need to disengage the boiler. So the switch just opens in that case and shuts the boiler off, turns the power off to it. So the first switch, switch number one, I'm off the page here already, switch number one, makes contact and turns the pump on, and switch 2 breaks contact and shuts power off to the unit. Okay, so that's our first line of defense. I'm going to keep a little table over here. The three things we care about for safety are low water, high pressure, and gas pressure. That's what we care about. So we're very worried about the first two particularly. So we have to have, just like a plane has, we have to have redundancy, and we have to have backups to backups. So the low water cutoff is the 150 valve, is the first line of defense. If it gets to be that low, the system shuts down. But that little ball can get gummed up. In fact, that's what's called blowing down a valve here, and it comes down, it just has an open pipe, and it allows you to open that up, and it just thrusts the water down. The idea is to like open it fairly quickly so the water comes charging down and just cleans out any sediment in there. You do that typically every day just because boiling water, you know, probably just as you know, boiling water tends to be kind of gunky, particularly when it's coming through old pipes and so on. So that kind of gums that up a little bit from time to time. So that cleans that out. But if it still gets stuck, we don't want to keep firing, let the water go down and down and down. So over on this side we have another valve, which is essentially the same thing, just another pipe that comes out, and a valve comes around, and it's a float. Slightly different design. This one is a 67 for us, and it's a model 67, and it also has two switches, but they're at the same level. So they both engage at the same time, but they're set even lower than this one is. So they're the next line of defense. So that would be the low water cutoff, 67, and then the second set of contacts in here, I actually had it wired so that that sends off an alarm. An audible alarm saying that we've got major problems, and that's battery backed up. So even if the power does go off and the water remains low, it's still going to keep on honking. And I think if it gets to that level, we're in serious trouble. Now let's look at the pressure. So those are the two low water cutoffs. Every boiler has to have at least two. And notice that they're on opposite sides, just in case there's some damage to the cast iron structure or something of that nature that causes the water to be uneven. The high pressure is over on this side of the boiler, and it's going to be a little hard to draw this, but basically there is just a tap coming off the side of the boiler up here where the steam pressure is going to be building, and it comes up into a little box called a pressure troll. And it looks like this. Not much to these things. And all they do is have the pressure comes up here, and there's a little spring in here, if you can believe that, and spring and a mercury switch that tips based on how much the pressure pushes this little plunger up and down. And you set it for a particular pressure. We'll get into that here in a second. So that's going to be the high pressure operating valve is the first one, because we actually want to only have the pressure go so high, and then we're going to shut it off, let the steam circulate, and then when it drops down again, we'll keep going. So this one is not so much a safety device as it is an operating device. So we're going to call that the operating control. Okay, and that's a pressure troll. And then there's going to be another one hanging off this as well. And it can be the same type of model. It can be different types of pressure devices, but same concept. And this is going to be the high pressure cutoff. So this may be, the operating control may be set for 1 pound, 1.5 pounds. The high pressure might be set for 4 or 5 pounds, saying that if it reaches that level, then we need to do the same thing as that low water cutoff did, and we just need to shut the power off to the boiler so that the flame goes out and the pressure will drop. So we have a pressure troll over here, which is the operating pressure troll, and then we have the safety pressure troll, and I didn't leave enough room for this big magic marker. And then thirdly, on this side, we have a just a mechanical device. It's a relief valve, the same kind of thing that's on your water heater. So it's just another valve that sits over here, and it's a mechanical valve that is set at the factory to go off, and usually they're 10 to 12 pounds. And what it does, it doesn't have any electrical characteristics to it, no switch or anything to shut off the boiler. It just opens and dumps out the pressure at that point. So that would be the third line of defense, which I can't quite get in here, so that's going to be the relief valve. Okay, kind of like the water heater has a relief valve. Alright, so low water cutoff has 3 lines of defense, high pressure has 3 lines of defense, and then the gas chain is similar to that. And that one I'm going to cover real quickly because it's not really a big deal for us. But again, alongside where I can't quite draw, the natural gas comes in and it pipes around the side and into where the burner is. And we have to have 2 gas valves so that they both are turned on at the same time for gas to come through, just from a safety standpoint again. But we also have to have a device up here, which is right by the burner, that senses gas pressure to make sure that it's not too high or too low. And then in connection with that, there's a flame sensor to make sure the flame is actually there. And if those two are the flame for the pilot at least, and then that activates the gas so that it comes in and lights the main flame, and then the sensor looks for the main flame, and if for some reason the main flame or the gas pressure gets too high or too low, then it shuts off one or both of those valves. So the same type of deal where you have the flame sensor, you've got a pressure control, you have a flame sensor, and that will shut down the unit if there's a problem with the gas. We're going to focus on the first two, the low water cutoff and the high pressure, because that's really where the lion's share of the issues are. This is the left-hand side, which is going to be over here. So you get kind of an idea of what it looks like. This is that 67 valve I was talking about, and you can see that it comes out of the boiler here and comes down around and it goes back in. You can't quite see that part. And then here is that sight glass and valves to shut the water off if we need to. I need both of those. Here's a gas valve. There's another gas valve inside of there, and here's the cutoff, and then the gas comes in here, and the other gas sensor is in there. And there's just a piece of plexiglass here, so this thing sometimes drips, so that keeps the electronics down below, or the valves down below, from getting wet. So that's what that looks like. And I don't really have a picture of the right-hand side, unfortunately, but the 150 valve is kind of an ugly beast. So it's this big steel ball, and I guess it goes like this. And this is taken apart for the season, so you can actually see inside. This is the piping that goes up, and and the piping that goes down, and then the water would just sit in here, and this is the part that sits on top of it, and then this bellows here extends out, and that's where the electronics are, or the switches are, and then the ball you can't see right here goes into there. So it's just a big old steel hunk beast, but very expensive. All boiler parts are very expensive because of the pressure involved, and the labor is incredibly expensive. So let's just take a real quick look at these guys. McDonnell Miller 150 low water cutoff, and that's what it looks like. The big ball there is inside the billows, and then up here are the mercury switches, at least the old mercury switches. We now have regular toggle switches that are in there. And this thing sells for well over $1,000. It's about $2,000 installed, and it only has like 8 bolts. So it just bolts on, and that's about it. So that just gives you an idea of how much they charge for this kind of stuff. Okay, this is a catalog page for the 67 low water cutoff, and a little different configuration, but again, there's just a little ball, and they're a lot smaller, and the switches are over here. And the one thing I didn't mention is that this one actually has a manual reset. So on the 150 over here, if you recall, if we hit the low water cutoff, it shuts the system off, but if the water regains, which it typically would, maybe just drop down for a few seconds, then the switch re-engages, and then the system starts back up again. So no big deal. The one over here, though, is a safety device. So once it gets to that level, you can't start it back up again. And ours, we'll get into that. Ours doesn't have that right now, but it's not a good idea to have the second low water cutoff hit and then just have it magically reset, because there's usually something wrong at that point, and you shouldn't be messing around with that. So there's just a little button you got to push to reset it at that point. Otherwise, it won't start back up again. Same thing goes with the high pressure. Pressure trolls look like this, and right now we have 2 pressure trolls in there, I believe, but when the system was first put in, we actually had something even worse, and the pressure trolls are not that great to begin with. But we had a pressure troll for the safety high cutoff, but we had one of these goofy little boxes like this, which is essentially the same thing, but it's just a far less precise device. It just basically has this piece of metal with a spring that sits on a little plunger inside of this tiny little steam pipe, and then that's supposed to be calibrated against some scale saying, you got 1 pound, 2 pounds, 3 pounds, based on a spring just going up and down, and you kind of like whack at one that goes plus or minus a couple of pounds. So it's not a very terrific device, but that's what was used for the operating control, and that's been replaced by a pressure troll at this point. But we'll talk about again about the problem with pressure trolls as well here in a little bit. This device is not terribly expensive, a couple $100. You can buy them brand new, on eBay or just through HVAC mail order place or a web place for probably about $125 or so, and it's just one fitting there to put on and two wires. So they're fairly simple to install, and they are somewhat considered a wear item because one, they're so critical for safety, but 2 is they just wear out like everything involved on the boiler near side trim, and that's what this piping and controls right around the boiler is called near side. All that stuff tends to only have a 3 to 5 year life just because of the abuse it takes. So in this case, it's a fairly reasonable cost. And this is kind of how it looks like when it's hooked up. There's usually a gauge over there so you can manually read it, and that's about it. So now the second high pressure, the safety one, is pretty simple. It just, when it hits a certain pressure, it just shuts the circuit off. But the operating one is a special type of control. It has actually 2 settings, and it uses a differential. If you remember the forced air furnaces, we had a differential there because we didn't necessarily want the call for heat and stop the call for heat to be at the exact same temperature. So it's just that it oscillates and tries to go from like 69.9 to 70 to 69.9 to 70.1. You want to have some kind of range in there of a differential. Same thing here. We don't want the pressure to get too high, so we want to shut the boiler off when there's enough steam pressure, and then re-engage it again when the steam pressure drops to where it's not able to circulate through the piping. So that would be the differential range. So the operating control is, again, that pressure control has 2 settings on it. Let's take a look at that real quick. Over here on the right hand side, you'll typically put in what your operating pressure is going to be. So we may say 1.5 pounds. And then on the one over here, we'll say what the differential is going to be. And we may say a 1 pound differential. So that means it's going to range between 0.5 pounds and 1.5 pounds will be the operating range. Now the wrinkle to this is that it can't just operate that way, otherwise it would never turn on. So it actually will operate from 0 to 1.5 pounds, and when it hits 1.5 it will turn off, or it will disengage, and then as the pressure drops, it only has to drop down to 0.5 to turn back on again, and then it brings back up to 1.5. And as long as it stays in this range, it'll just go back and forth. Once it drops below the 0.5, then you have to start over again. It has to go back to the 0, and that would be because there's no more call for heat. So it just lets the steam pressure bleed off, it drops to 0, and then when there's a call for heat again, the thing starts over again and goes from 0 up to 1.5. So that's the one aspect of that particular pressure control that is somewhat unique and does confuse some people because of that differential. A little bit about radiators and so on. I think they're, for the most part, pretty self-explanatory. It's a 2-pipe system. You got the radiator up here. Bring this down a little bit. It's just got the sections in my horrible drawings, and they're all hooked together, and the steam comes in through a valve with a control like that, and then down the bottom on this side it comes through what's called a steam trap, and then goes back as water. So steam comes in and water comes out. This is just a simple valve, just like you would have on home plumbing. It's no big deal, other than the fact that, of course, it's expensive and it's a steam certified type device, but it's just a valve to regulate how much steam goes through the radiator. And we'll again talk more later about why that's not quite as simple as it seems. And the other thing that's typically on here, if it's at the end of a run or of a long run, there's going to be a little air vent sitting off to the side, and they kind of look like this. These are almost always forgotten, but extremely critical for even heat and energy efficiency. All they are is just little pressure devices that allows excess air to escape. So as you're moving steam in for the first time, this thing's all filled full of air. The air's got to go someplace, and it can't go down this way because, as we're going to talk in a second, there's a steam trap here which blocks that. So it just builds up air pressure, and the steam kind of gets stalled, partially coming in. So somewhere along the line in these radiators, you need to have these vents. And there's a huge vent down in the boiler room at the end of the line, but you typically want to have them, for example, in the 2 restrooms. That's a major problem because you're moving the length of the building worth of piping plus the radiators just to get steam down there. And if you have to push air along the way, it's going to be a long wait. Otherwise, it should not be very much of a long wait at all. The steam moves very rapidly. So that's and they get plugged up as anything, need to be replaced, but they're very reasonable in the $50 range, depending on if they're just for one radiator or for an entire line. The steam trap is, I'm sure you've seen these. This is like a MEPCO trap right here. They've been around the building. Right now I believe they're gold. They look like this. This would be hooked up to the radiator, and this goes down through the floor. And all they do is they separate steam from water. So there's this little tiny disc in here, and it's got this thermostatic device. So this thing goes up and down, and it moves a lot, thousands and thousands and thousands of times each year, and that's why they wear out. But it allows the steam to it closes when the temperature is such that it's still steam. As soon as it cools to become condensate, then it opens it a little bit and lets the water trickle down and then closes again. So it sits there and oscillates back and forth based on temperature to keep the steam in, and then it lets the water out. Otherwise, you would just have the steam making a round trip and we wouldn't get very far. So the steam traps are critical. If they aren't working, they typically stick open, which means the steam just makes a round trip and ends up going into the recovery tank downstairs and just going out the main vent and just being wasted energy. So not a good plan. Plus it causes all sorts of carryover and hammering and things of that nature that is really quite hard on the system and drives up enormous energy bills. So we're going to talk a lot more about radiator traps. There's also end-of-line traps, which look just like radiator traps, although some of them are much, much bigger. But at the end of the line, you have to get rid of the excess moisture. So as the pipe continues throughout the building and the last radiator, you still have to get rid of the water that's coming out of that. So at the very end, there's going to be another big old, huge, if it's like the main headers here on the two office floors, a big old steam trap that's just going to let that condensate through. Just out of interest, this is what the control area looked like when I inherited it. So here is the boiler over here. This is the giant flue going into the chimney, and this is one of the steam header takeoffs. And this is actually the relief air shaft that goes all the way up to the attic, but the controls, it's hard to even see, but it's just a relay and some hard wiring that was just stuck to the wall and basically just kind of like taped together and somewhat labeled, and that was about it. Over here is the pressure troll and the manual gauge and so on, and the wiring kind of went down here, but it was hard to trace, and certainly you had no clue what was going on. If something was wrong, you didn't even know really if the system was running or not. It just had this relay that hooked into the thermostat up in the chapel. So this is what I did, is to just put a piece of plywood up on the wall, nothing else. But to organize it, put in the maintenance logs, the required safety postings and so on. And then this is the transformer for the thermostat, which goes back upstairs. Boiler power, just some outlets. You can put some lights around the thing when we're working on it. And then this control panel, we'll go into this in a separate video, but this allows us to see what the thing is doing. And then these wires all go over to the boiler so that there are individual sensors at each one of those low water cutoffs, each one of those control points, so that a light will tell you if it's working or not. And then you naturally can troubleshoot it very quickly, and it's good for lay people, or if there is some type of problem. And there's the buzzer if there is a second low water cutoff. And just for the heck of it, this is my official MCC, Museum of Creepy Old Boiler Parts. So you have to have kind of a sense of humor and actually a sense of history, because some of this stuff is just, I don't know if it's creepy or what, but a lot of asbestos and things of that nature were actually advertised as being just great things back in the day. But kind of the reason for showing that this is the 150 low water cutoff. We have an extra one of those, and that's a gas valve, and this is a steam trap, and this stuff is actually the scary Frankenstein contactors and fuse panel for the old blower motor on the big old furnace. So those were just creepy as they were.